Okay, hi, welcome. This is a video on how to use standard form quadratics to analyze parts of it and get information and then use that to graph it. So in this case, we've been asked to take this equation, f of x equals 3x squared minus 6x minus 1, and find the vertex, the axis of symmetry, the y-intercept, and then to use that to graph the quadratic, and then also we will state the end behavior. So I've copied it over here. I want to make sure that I've copied it correctly. Check to make sure that that's a very common mistake. I switched out f of x for y. It's the same thing. F of x is y. So the standard form of a quadratic equation is ax squared plus bx plus c. And from this we can see that a is 3, that b is negative 6, and that c is negative 1. So I'm going to just keep track of this. You don't have to use colors. I'm just doing that to help you see. A equals 3, B equals negative 6, and C equals negative 1. We're gonna use that information. And although it asks for the vertex first, we're going to use the axis of symmetry first to find the first part of that vertex. So we're going to do this one first. And something to keep in mind about the axis of symmetry is we have a formula for that. When we have standard form, we can go to x equals negative b over 2a. I like to put it in musical terms and say it like this so to help you remember. Negative b over 2a. Okay. So I'm going to write negative. The negative is this negative b. We don't know if b is positive or negative. When we have this formula, it's just the opposite of whatever b is. So this is b is negative 6. So I'm going to put negative 6 in parentheses. And then I've got 2a, and a is 3. So I'm going to put 2 times 3. And then just evaluate it. The opposite of negative 6 is positive 6. And 2 times 3 is also 6. And 6 divided by 6 is 1. And so the axis of symmetry is that equation x equals 1. So I'm going to kind of start graphing already here. I've got I got this line here. This is my y-axis, and this is my x-axis. I'm going to call this point 1, and here's 2, and there's 3, negative 1, negative 2. And then I've got negative 1 in y, negative 2, negative 3, negative 4, negative 5, negative 6. And then, so the line x equals 1, let's color that. Let's color it this color. And that is going to be right here at x equals 1. And it's a vertical line. We're just going to draw it as a dotted line that goes up and down through x equals 1. And so that line, that's our axis of symmetry. And it gives us symmetry for our parabola, which is the graph of a quadratic. Then we're going to go to the vertex. And as I said, we found part of the vertex by finding the axis of symmetry. So this x equals 1, we know here that x equals 1. Now we just have to find what y is. And every point on this line, and on any line, is in the form of an ordered pair. An ordered pair of x, comma, f of x. Now we could put y there, but I kind of like calling it f of x because then I think I know what x is, I plug it in, and I find a value of y for that value of x. And so I go here, I know what 1 is. I'm going to erase this right here. I'm going to recopy this as y is equal to 3 times something squared, that's my x squared, minus 6 times something, that's my minus 6 times x, and then I've got minus 1. And what am I going to put here where x was, and what am I going to put here where x was? Well, x is negative, or x is 1, so I'm going to put 1 that value of 1 there, here, and here. And then I just evaluate that. So, hey, 1 squared is 1 times 3 is 3. And minus 6 times 1 is minus 6. And then I have this minus 1 off at the end. That's minus 1 still. Well, 3 minus 6 is minus 3. And minus 3, then minus 1 is minus 4. And so y equals minus 4. So in my vertex, I come down here and I just put that in there, minus 4. So I've got the point 1 minus 4. I can go over and put that in my graph. Well, I go down 1, 2, 3 to minus 4, and that point, 1 comma minus 4, is my vertex. So that's the point where the graph turns. Now I need to find the y-intercept. And something to keep in mind about y-intercept is that they always happen where x equals 0. And so my y-intercept, I know, is going to be some ordered pair where it crosses the y-axis. And it crosses the y-axis when x equals 0. Just like up here, when I knew that x equals 1 to find the vertex, well, here to find the y-intercept, I know x equals 0. So I can go back to what I had over here. I can kind of erase this part right here and just say, hey, instead of 1 for x, I'm going to put 0 here and 0 there. Well, 0 squared is just 0 times 3 is still 0. This is all 0. Minus 6 times 0 is also 0, so you can put plus or minus. It doesn't matter. And then over here, I've got that minus 1, so that's still there, minus 1. 0 plus 0 is 0, and 0 minus 1 is minus 1. So y equals minus 1 is my y-coordinate of my y-intercept. So 0 minus 1, I can go over here to my graph and write, okay, 0 minus 1. I've got that point right there. But hey, because of this axis of symmetry, this is 1 unit here from the axis of symmetry. So I go over here 1 unit on the other side, and I've got another point on my graph. And now, with those 3 points, I can kind of graph a sketch of what this parabola looks like. Its vertex is right here, so it goes up from there and off in that direction. And then this one goes up through my y-intercept and goes up in that direction. And so this is kind of what it's a sketch, but that's what my parabola looks like. Now, in terms of its end behavior, this is where we say x goes to negative infinity or x goes to positive infinity. This just says what happens when my x goes to the left? What happens when the values of x go to the right? What happens to our graph on the left side? What happens to our graph on the right side? Well, on the left side, let's use blue here. I can say as x goes to the left, as we go up here in this direction, what's y doing? It's going up. So I can say y goes to positive infinity because it's going up. And let's use orange. So y goes to positive infinity just says y is going to the right. So what happens as we're going off here to the right? It looks like, well, y is also going up. So I would just say y goes to positive infinity because it's going up. And that's what this graph looks like. Practice. You got this.